Welcome to the Introduction to Analysis for the Cynthesizer Workbench, one of a series of basic training videos for the Workbench. In this video, I'll introduce the basics of analysis of results, focusing on the results from running Cynthesizer. Once you understand the basic content and how to manipulate the views, it should be relatively straightforward to find your way through the system on your own designs. So we're going to take a look at analysis in the context of a concrete example. This is the edge detection filter which is shipped with the Cynthesizer Workbench product. In the bottom left-hand corner of the sidebar here, we see the Synth project. This pane contains all the objects that are relevant to your synthesizer project. Any object in this tree that represents the results of any process run, for example, a simulation or a synthesis run, can be analyzed. Here in the tree, we see we have a single synthesizable module called filter, and it has multiple synthesis configurations. Each configuration may use different settings, flags, and synthesis directives to produce a range of completely different hardware implementations from the same source code. Now, for any analyzable object in this tree, we have multiple ways to access analysis. We can right-click and select Analyze, same for the synth config, or we can simply double-click. Here we see the analysis view for a synthesizer module, and what this contains is a summary of the synth config data for that module. Here I've already run 4 different synth configs, and you can see the summary data for each. The histogram shows summary data for each synth config, and we may find one of those interesting and want to push down in more detail. We can do that by simply right-clicking and choosing Analyze, or, as we mentioned before, going to the tree and double-clicking. Now this view is the view of analysis for a synthesizer configuration. As you've noticed, this is quite different from that for a synthesizer module, and it's very important to point out that depending upon the context of what you're analyzing, the views are necessarily quite different, since the data that's being presented is very, very different. So for a synthesizer configuration, we have a number of tabs. Here we see the summary tab. We have messages, which is empty for this one, but if there were any kind of warnings or notes, they would appear here. You can double click them and go directly to the source location. Here is the log file, and you can scroll through these. These persist for as long as the data is available on the disk. We have the parts tab, and we can go into this table and we can sort this by area so that we can look at the things that are of most interest to us, which are probably the larger parts. We have a register table. Again, same kind of thing. We can sort this by, for example, width, and look at the larger registers first. Muxes, same kind of thing. There are also a number of other tabs. There's a lot of data that can be represented here, and this tab list can get quite crowded, so it's very useful to be able to remove and show the tabs that you're interested in at the current time. So I'm going to go ahead here and add a source tab to view source files, close the muxes, and open one of the source files. Now it's quite common here that I want to look at more than one thing at once, and so having a tabbed view like this is not really very productive. What we allow you to do is to select one of these tabs and say move it to a new pane, and we can either make that side by side or above and below. So I'm going to move this to a new side by side pane. It'll split those. Since I need more real estate here, I'm going to go over and close the sidebar, and I can maximize my views. Now, for example, I can go over here to the parts table, and I might want to say what is the functionality of this filter and where did it come from. Now, each row in this table, as it is right now, represents a complete component or part in the design. If we open up that particular part tree, we can see that they have child elements, and those child elements represent the operations that were mapped to that part. What we call an operation is a symbol in the system C code, for example, a plus sign, that ends up mapped to an actual adder in the hardware. And as you know, a single adder part can be used to implement a number of operations from the original code. So we can select any one of these operations and say show selection in C++ source. And over here in my source code, that has now highlighted this body of code, And I can tell, because I know that that filter body tag actually has a CynDP-Opt inline underneath it, that this is a single part representing the entire body of code from one curly brace to the other that you see highlighted here. If I go and look at a plus part in the source code, it will highlight that in its location, and I can tell exactly where that operation came from. So that way I can easily determine what caused this part to be there and what code implied that part. Now I can also go to this part and say show it in my RTL C++ code. And it will show my RTL code, and it will highlight where that part is instantiated in that code. This is one direction that you might want to go, where you have a particular part in the table and you want to find out where it is in your RTL C++ code. Now what I might want to do is go to, for example, this adder in my RTL C++ code and see where it came from in the source code. Now in this case, we know that this adder actually was implied by 4 different plus operations in the source code. It's highlighted one of them here, but here you can see in this window at the bottom that I have a tree structure that identifies the lines of code for each operation that was mapped to the actual adder part. I can go down and double click each one of these and it will take me to those in the source code. And those 4 lines correspond to these 4 adders that you see in the operation branches of the parts table for that adder as well. This is very important functionality that enables you to do bidirectional tracing between source code, generated code, and parts tables and register tables. So let's clean this up a little bit here and go back to our sidebar. Now here we've looked at the analysis of a single synthesis configuration. Many times we actually want to compare synthesis configurations. So we've looked at the basic DPO configuration here. If I double click on the basic configuration, I can look at that as well. And in the same way that I want to look at those side by side, I can look at entire contexts side by side. Again, I'll get myself a little real estate here and go up to the split button in the top right of the window and choose side by side. And now you can see that I have duplicates of the basic, and I can click here and select a different configuration that I'd like to look at. And here now I can look at the same views for each of the configurations. So for example, I could go and compare the parts tables. Sort these by area. And I see I have one set of parts for this basic configuration and a completely different set of parts for the DP-Opt configuration. It's very useful to be able to compare different implementations, understand what happened between them, and take a look at them in more detail. Now to close that split, I simply click on the Remove Split button and go back to my individual list here. Now there are a lot of side features that are available with this kind of functionality. So for example, I have complex filtering, where I can select a filter, I can filter by area, I can filter by delay, so that I'm only looking at, for example, the parts that consume the majority of the time in the cycles, or I can only focus in on the parts that are the big parts, for example, if I'm interested in area reduction. If I'm looking for something by name, I can just put in a string here, and it will find me anything that matches those strings. So this kind of filtering is very useful functionality. That concludes our demo on Introduction to Analysis. It's worth noting that I've only covered the very basic analysis functionality in this video, but it should serve as a means to get you started on your own. Please review the other videos in the series to learn all the common tricks for getting up to speed as quickly as possible.